Suppose there is an amount K and this amount is due for payment T years after the present date. That means after T years, this is due for payment T years after the present date. That means after the present date, after T years, we have to pay this amount, which is K. Now the question is, what is the present value of this amount, K, which is due for payment T years after the present date, when the interest rate is P% per year? What I mean to say is, how much we have to deposit today such that we get an amount K after T years, given the fact that the deposit we make today, that earns an interest rate of P% per year. So the question here is, what is the present value of that amount K, of the amount K, when the interest rate is P% per year. The question is, what is the present value of this amount K when the interest rate is P% per year? That just means how much do we have to deposit today so that we get an amount K, how much we have to deposit today so that we get an amount K after T years, given the fact that our deposit earns the interest of P% per year. That means I want to know the present value of the amount K when the interest rate is P% per year. Let us say the interest is paid annually. Then if I'm concerned about what happens after T years if I deposit the amount A. So let's say that the interest is paid annually. Interest is paid annually. If interest is paid annually, and let's say we deposit an amount A, and I know that interest is paid annually, after T years, this amount will increase to this 1 plus P by 100 raised to the power T. And the point is, after T years, we need to get that amount, we need to make that payment, which is K. So after T years, this should be equal to K. And that means here I want to know what is this. So this is the present value, capital A, this is the present value. So this A is actually equal to K multiplied by 1 plus P by 100 raised to the power minus T. Or I can write K 1 plus R raised to the power minus T. And here again R is equal to P by 100. So if interest is paid annually, this is the present value of the amount. This is the present value of the amount K when the interest rate is P% per year, when interest is paid annually. Let us say interest is compounded continuously. Then if I make the deposit, if I deposit A right now, then that amount A, then that initial deposit A would increase to this after t years. A e raised to the power rt, it will increase to this after t years when the interest is compounded continuously. Now this should be equal to capital K. And again, here A is the present value that I'm concerned about, the present value of the amount K when the interest rate is P% per year. But please keep this in mind that the interest is compounded continuously. So here A is equal to K e raised to the power minus RT. So in this case, this is the present value. This is the present value of the amount K when the interest rate is P% per year, given the fact that interest is compounded continuously. So that leads us to this conclusion that if the interest rate is P% per year, let's say interest rate is P% per year, and R is equal to P by 100. If this is the case, then if we take up an amount K that is payable in T years, an amount K that is payable in T years, what that means is that after T years, this is the amount that is due, in the sense that after T years I need to make this payment of K that is payable after T years, and this amount has the present value it has this present value K multiplied by 1 plus R raised to the power minus T. This is when you have yearly interest payments. And that amount K will have this present value K e raised to the power minus RT when there is continuous compounding of interest. Continuous compounding of interest. So the point to note is that we need to pay an amount K after T years, as in that amount K is payable after T years. What is the amount that we have to deposit today so that we can get an amount K after T years, and if that is the case, we can make that payment after T years. So given the fact that there are yearly interest payments, that amount K which is payable after T years, that amount has this present value K multiplied by 1 plus R raised to the power minus T. This is when we have yearly interest payments, that means interest is paid after each year. But if we have continuous compounding of interest, then that amount K will have this present value, which is K e raised to the power minus RT.